We can understand Newton's formula by using this simple toy basketball. Okay. By playing this toy basketball game, we can understand Newton's formula very easily. Arrangement of this toy is: this is a spoon, this is a small ball, there is a spring, there is a basket. Okay. Right. When we press this spoon, by pressing this spoon, we make sure that ball should fall into the basket. Okay.
Please.
కొంచెం స్లో.
Pressing of the spoon is action. The falling of the ball into the basket is reaction. This action and reaction are equal and in opposite direction. This is the floating ball experiment. Here in this experiment there is a magnet inside the ball. So this pole is south pole. There is one more magnet here to this stand. This is a north pole. Okay. You know already that unlike poles attract each other, like poles repel each other. This is a north pole, this is a south pole. So there is a attraction between these two. There is a magnetic force, magnetic field. There is a magnetic field. The direction of the magnetic field is from north pole to the south pole. Right. If we keep the in front of the if we keep the object between these two, let us see what will happen. See here, the ball is not falling down. When the ball is not falling down, that means this object is transparent to the magnetic field. Transparent to the magnetic field. Let's see, this is a cardboard. Let us keep this cardboard between these two. See, again the ball is not falling down. That means this is also transparent to the magnet. This is a metal. It's a metal. So metal. This is a zinc metal. Let us keep this. This is also transparent to the magnetic field. The ball is not falling down.
Yes, sir.
So transparent. That means look at this is a copper. So copper plate. Let us keep this one here.
This is
Again, this is not
transparent to the magnetic field.
and the ball is not falling down.
Yes, sir.
Also, this is also transparent to the magnetic
field.
That means this also allows the magnetic field through it. Here, this is a aluminium foil. You know this aluminium foil.
Yes.
See, again it is not falling. Ball is not falling down.
Yes.
See, this is also
Transparent to the magnetic field.
So also aluminium foil. So 8 folds. 8 folds. See, ball is not falling down.
Yes, yes.
So this material also transparent to the
Transparent to the
magnetic. This plastic cover also transparent to the magnetic field. And this is plastic. This is also transparent to the
magnetic field.
That means magnetic field line passing through this plastic also. So these objects are the. So this is a iron hexablade, iron material. So when I keep this bit not falling down.
Yes,
So here this is material, iron material is attracted by the magnet. There is a magnet. So this is the north pole and this is the south pole. This is the magnetism is induced into the iron material, and this will become temporary magnet. And this is the south. Again, this end will become north. So north and the ball magnet is this is the north, ball magnet is south. So there is again attraction. This experiment name is induced magnetism in rolling balls. For this experiment we need rolling balls. So more radius, this is having more radius, bigger ball bearing, and this is having less radius, smaller ball bearing, and this is an inclined plane. There is only 2-point contact. So this is an inclined plane. So if I keep the ball bearing here, what will happen? Let us see. What is happening here? Rolls down. Okay. If we keep the second one here, smaller ball bearing here, let us see what will happen. What is happening here?
It is also rolling down.
Yeah, it is also rolling down. Now I am keeping the bigger one in front of the smaller one and release. What is happening here?
The bigger one is fast.
Move faster. Bigger one moves faster, right? If I reverse it, that means the smaller one is first and bigger one is second. Let us see what will happen here. Here, how they are moving?
The
They
bigger
are
one
moving.
is pushing.
Yes, they are moving together. Why? Because they are moving together. Why? Because the bigger one is pushing the smaller one. Okay. Now the interesting part that we are going to discuss. This is a magnet. Here, these are the iron ball bearings. So here, the magnet is attracting the ball bearing. See, observe. Magnet is attracting the ball bearings. Right? Okay. I am putting the magnet here. Okay. You observe this one. Rolls down and attracted by the magnet. I will keep this. It also rolls down and attracted by the magnet. Right. Now I am releasing the ball bearings here. I kept the smaller one first and bigger one next, and releasing. They are stuck in here. Why? So there is a rolling friction between, when the balls are rolling, there is a rolling friction between the surface of the track and ball bearings. When the ball bearings come into the field of magnet, these ball bearings will get magnetism, induced magnetism, and they will stick together. They will get induced magnetism and they will stick together. When they stick together, this ball bearing trying to move in this way, and this ball bearing trying to move in this way. So that there exists some extra force between these two. There exists some extra force between these two. That force is called friction. That is called friction. Then these two ball bearings becomes one body. So they stick together, they become one body, and the friction between the surface and the ball bearings is becomes sliding friction. See here, is no longer ability to rotate. This is why it will become sliding friction. So no longer, observe here, no longer to ability. So the friction between the surface and ball bearings. See, rolling friction value is much less and the sliding friction value is much more. So that is why even though there is a magnet, the balls are stuck. Understand the gravitational force, that is centripetal force and centrifugal force by this activity. These are falling due to the gravitational force, that is centripetal force. So when we rotate fastly, all the buttons are pushing away from the center. This force is called centrifugal force.
Centrifugal force.
So the object is at rest on his head. The object which is at rest will try to remain at rest. So that is what? First law is inertia. So inertia is the property of every object. So here Akshit, you move to there is a rubber band. The rubber band is not here itself, but the ball which is comes into motion, that try to remain in same motion. So this is a Bernoulli principle. Let's see. This is a hair dryer and this is a small table tennis ball. If I keep the ball, the ball is, why the ball is keeping on floating always? Why the ball is keeping on floating always? Here, the speed of the air is, the velocity of the air is higher, then the pressure will be less. If the pressure is less here, if the ball try to move in this direction, if the ball try to move in this direction, if the ball try to move in this direction, here there is a velocity of the air is high and the pressure will be less. This side, the surrounding air, the pressure will be more. Then the surrounding air pushes towards the maxima, central maxima line. If the ball try to move in this direction, this side the velocity of the air is high, and the pressure will be less. And the surrounding medium, this side air is less speed and pushes in this direction. So always the ball floats in the central maxima line. Wherever the ball try to go, the surrounding air push the ball towards the maxima central line. If I change the angle, also it does not fall down. Sometimes, always we think that if I change the ball, change the angle, the ball will fall down due to gravitational force. But it is not correct. So, the ball keeps on floating on the central maxima line. When the angle exceeds the critical angle, here the ball
transparent the magnetic. So మనం అనుకుంటే కట్ అయిపోతుంది మళ్ళీ కాపర్ సో ట్రాన్స్పరెంట్ ది magnetic బట్
అక్కడే ఉంటాయి అన్ని లాగేస్తాం నువ్వు ఇట్లా నువ్వు నాలా తీసుకొని నువ్వు తాగాలి నాలా రైట్ లైన్
చిన్న జర్రా